Hello friends, you are watching the Being Mathematician. Today I going to share you a complete class on the chapter height and distance. Before we start, we have to revise the triangle formulas of trigonometry. Let's have the look. Let us assume the triangle ABC when angle C is theta and BC is called base. Angle B is right angle and AB is called height, and AC must be hypotenuse. Now, the first formula, that is sin theta, is equal to AB by AC, and cos theta equal to base by hypotenuse, that means BC by AC. Tan theta equal to height by base, that means AB by BC. Cot theta is equal to the reciprocal of tan theta, that means BC by AB. Sec theta is reciprocal of cos theta, that means hypotenuse by base, that means BC. And cosec theta is reciprocal of sin theta, that means hypotenuse by height. Why we have memorized this formula? Because these formula are very important for this chapter. Let's start the chapter introducing the angle of elevation. Let us assume that this is a building, and one person stand here, and one point on the ground, and from this point one person see this person, and this imaginary line mentioning that, and we imagine another line which is parallel to the horizontal line. Now we find an angle between these two lines, this angle. We say about this angle, this is the angle of elevation. Suppose in the same condition, that is a building and one person stand here and one person stand here whose height is not negligible. Then this person see this person mentioning this imaginary line. Then in the same way we can imagine a line which is parallel to horizontal line, and the angle between the lines is also called as angle of elevation. Now let's see the next important topic of the chapter, that is angle of depression. Same as previous, let us assume that this is a building and a person here see a point on the ground or a thing on the ground which height is negligible. Then we can imagine another line which is parallel to the horizontal line, and the angle between these two lines is called angle of depression. We see the case when that height is not negligible. This person see this along this line, and we can imagine a line which is parallel to the horizontal line, and this angle also called angle of depression. You must be careful about one thing, that is, in this case, this is a building and one man standing here and see a point on horizontal. Then most of the students assuming that this angle is angle of depression. So this is absolutely wrong. The correct angle of depression is this angle. So be careful while making figure from the word problem. Now we have to see how we utilize the trigonometric triangle formula to solve the problem. As we all observe that in the case of angle of elevation or angle of depression, we will get a right angle triangle. Let it be clear. This is a right angle triangle in the case of angle of elevation as well as angle of depression. So we name the triangle A, B, C, and this angle is theta, which is angle of elevation. Let's see the important tricks to solve the problems. So, number 1, if we want to determine AB in this figure, then apply tan theta or cot theta if BC is given, or apply sin theta or cosec theta if AC is given, because we know that in the formula of tan theta, AB and BC are involved, and in the formula of sin theta or cosec theta, AB and AC are involved. So, let's see the number 2 trick. If we want to determine BC, then we apply tan theta or cot theta if AB is given, because tan theta and cot theta are in reciprocal relation. Or apply cos theta or sec theta, triangle property, when AC is given. Since we know that AC or hypotenuse and BC is base are involved in the formula of cos theta or sec theta. Now let's see the trick number 3. If we want to determine AC, then apply sin theta or cosec theta when AB is given, or apply cos theta or sec theta when BC is given Now let's see the illustrative examples and how to solve the problem sums. Type 1. Let us assume that this is a building and this is the horizontal line, and from this point C, the angle of elevation is 60 degree, and the distance between this point B and C is 10 meter. Then find the length of the building. So as our tricks, we can apply in this triangle. This is assume that A, this is triangle ABC, tan 60, because tan theta is involving with AB and BC. So in this sum, BC is given, so we can apply tan 60, which must be AB by BC. And we know that tan 60 is root 3, so this will be AB by 10, and AB equal to 10 root 3 and 17.32 meter approximately, where root 3 equal to 1.732. Is it clear to you? If you have anything to say, please say it in this comment section. Type 2. More than one angle case. Let us assume that this is a building and this is another building. From this point on the first building, and one point, assuming one point on the ground is C, from this point to this point, angle of elevation is 60 degree, and from this point to this point, the angle of elevation is 45 degree. If the height of the building from horizontal to this point is 20 meter and height of this 15 meter, then find this point B and D, find the distance between B and D. So now this point consider as A and this point consider as E, assuming this triangle ADC. Tan 60 equal to AB by BC, following the tricks, and now putting the value of 60, that is root 3, and AB is 20 and BC is BC, then BC must be 20 root 3 by 3 meter. Now consider the triangle DCE. Tan theta is equal to DE by CD. So tan 45 degree equal to 15 by CD. We know that tan 45 is 1. So CD will be 15 meter. So BD is equal to BC plus CD. BC is 20 root 3 by 3 and CD is 15. So the approximate value is 26.5466. So that will be 26.55 approximately. So we got the length of BD. Type 3. Let's see the problem. Let us assume that this is a building. And this is a ship 1, and this is another ship 2. One person standing here and see first ship at the angle of depression 60 degree, and then it see the second ship at the angle of depression 30 degree. So we can imagine a line which is parallel to horizon in that way. So we must say that this angle is alternate to this angle. So this angle will be 60 degree and this angle is alternate to this angle. So this angle will be 30 degree. And now considering this triangle in the below, this angle is 60 and this angle is 30. So A, B, C, D, we name them, and this length, the distance between the ship is given, that is 10 meter. What will be the distance between the first ship to the building? Now let's see the solution. Let us consider triangle ABC tan 60 equal to height by base, and tan 60 is root 3 equal to AB by BC. Therefore, AB is equal to root 3 into BC. This is equation 1. Now, in triangle ABD, tan 30 is equal to AB by BD. So tan 30 is 1 by root 3. So AB is equal to BD by root 3. And this is equation 2. Now, from 1 and 2, we get root 3 into BC is equal to BD by root 3. Now multiplying root 3 on both sides, we get 3BC equal to BD. So BD is BC plus CD by the figure. So 2BC equal to CD. Therefore, BC equal to 10 by 2, that is 5 meter. So distance between the first ship to the building is 5 meter. Type 4. Let's see the problem. Let us assume that this is a building and the building is divided in 3 parts. Number 1, number 2, number 3. And from this point and this point, two men see this man at the angle of depression, that is 60 degree, and this person the angle of 45 degree. So we can consider this triangle in the below. This angle is 60 degree, so this angle will be 60 degree because the angles are alternate angles, and this angle is 45 degree, so this angle will be 45 degree, and the distance between the person and the building is 10 meter. So find the distance between these two persons. Let's draw the picture clearly. Let us consider that this point is A, this point is B, this is C, and this D. So in triangle ACD tan 60 is equal to AC by CD. So we can say AC equal to 10 root 3, since we know that CD is 10 meter and tan 60 is root 3. So, and now consider the triangle BCD. So tan 45 degree equal to BC by CD. So as tan 45 is 1, so BC will be 10 meter. So this is 1 and 2. So clearly length of AB is equal to AC minus BC. So AC is 10 root 3 and BC is 10. So 10 into root 3 minus 1, and it will be 10 into 0.732, because root 3 is 1.732. So it will be 7.32 approximately. Now let's move to another important topic. The topic is subtended angle. Suppose this is a lamppost and this is a person, and from this point to the observer's eye we connect a imaginary line, and from this point to observer's eye we can draw another imaginary line. So the lamppost subtends an angle of x degree to the observer's eye. So this angle is x degree. I think the concept of subtended angle is clear to you. So I hope you understood the chapter very well. So follow the examples of your books very carefully, then do the sums in your exercise in the book. So good luck, and don't forget to subscribe this channel for such important and interesting videos. And if you feel that this video is very useful to you, then please share it to your friends.